After looking at my answer key, I realized after the 3 problems I did in the first video, none of the problems had was one of those rare cases, or I guess special cases we could say. So number 6 turns out to be a special case, so I wanted to address that. And so anyway, we see we have an equation here that neither side is simplified, so we're going to go ahead and simplify here by removing the parentheses by using the distributive property, 2n minus 4, and we have plus 5. And over on the right side, again, we distribute the 2 through this binomial here. We have 5 plus 2 times n is 2n, 2 times 1 is 2. So on the left side, we get 2n plus 1, and on the right side, we get 2n plus 7. So there's an issue here. Normally we like to try to choose sides, and if we choose sides, we could see, well, regardless of which side we try to put the variables on, we're going to subtract 2n from both sides, and then we're going to get a statement that says 1 is equal to 7, because both of the 2n's, when you subtract 2n from each side, the n terms go away, and you get a statement 1 equals 7 that is never true. Now when you get statements that are never true, we conclude that we say therefore there's no solution to this particular equation, because regardless of what you put in for n, what real number you replace n with, there will be no real number that will make the statement true, because regardless of the real number you plug in for n, the n terms will cancel each other out, and you'll get a statement that can never be true. So therefore we say no solution. Alright, let's scoot on over and look at number 12 on the back side. So for number 12, again, we've got a situation where we've got fractions, and when every denominator is the same, that would be the lowest common denominator. So what we're going to do here is we're going to multiply both sides of the equation by 3. And I'm going to do this a little differently this time. So I'm just going to write a 3 next to the left side, showing those 3's canceling, and on the left side we get negative 7. On the right side, I'm going to show 3 being multiplied, or is that 3 terms? Okay. So actually, I would not multiply by 3 both sides. I didn't notice this at first, but if you look back on this, if you combine like terms on the right, v here and a minus v there, those cancel each other out. So we don't have to distribute the 3. All we have to do is multiply the 3 by this negative 7/3. And just like we did on the left side of the equation, 3 times negative 7/3 is negative 7. So unlike the last problem that we just did, this problem here, we get, regardless of what the variable is, or regardless of what you replace the variable with, you're going to get a statement that is always true. And when you get a statement that's always true, regardless of what real number you replace the variable with, you would conclude that it's an identity, and you would say therefore the solution to this equation is any real number will work. So you would say all real numbers. So that's how you handle statements that are always true. Statements that are always true, the solution is all real numbers. And statements that are never true, the solution would be no solution.